Hello everyone, and welcome in this talk. I'm Yvan, and I work at IOG on Haskell.NIC, so this talk is not really linked with my company. I opinion on my own, everything. And there is a little URL here. If you go on it, you will be an SSH link, and if you enter this link in your fancy terminal, you will have exactly the same thing that's on my screen, so you can copy paste everything. So, and sorry for my French English accent. And what's behind this really fancy and endily vague title of I want to talk about my personal quest of interoperability and technical challenge I take really seriously since a long time, and I sort of realized that a lot of commercial developers around me are not really comfortable with this problem, because we have basically one software that run into one runtime. For example, let's say Rust, another one which is in another runtime, let's say C or Python or Haskell or whatever you want. Or it could be, for example, two Rust versions, two different versions, or two pieces of software that's spontaneously you feel like it will be hard to mix it together, because I have to decide how to communicate between my two programs, share data structure, and how I should bundle all that and distribute it, and that's the point of many build systems and package manager and big part of computer science. The second part, I will not really talk about it in this talk, that was a bit shrinked, so feel free to talk with me at any time. I really can talk about any subject introduced here. And for example, the case we could have is, I don't know, I have a library and I have a personal project and I want to use the library inside this project, and the library is not written in the same language, or I'm in a big company, there is a lot of legacy code, and it's not reasonable to rewrite it from scratch, because usually that's the kind of things it's hard to make validate. So I'd rather want to rewrite piece of my software. So in all of these cases, I have this painful issue of interoperability between different pieces of software. And so when we have a lot of solutions for a problem, we usually want to rate all these solutions. And in Rust, we often see this diagram for sponsoring commercially the Rust language, where Rust say it live with the little rainbow. It's also safe and fast together. And I'll try to talk about different interoperability solutions on this diagram. And also I realize that from the Rust folks around me, there is maybe half of the persons that come from a really system programming background with fast programming language. Fast is big, ambiguous as a term for speaking about a programming language, but with a small runtime, and that looks for safety coming to Rust. And there is the other side of developers that's coming from script language, web, mobile, or other parts where computer science, where language are usually safe. It's hard to do an int overflow in Python or a segfault or this kind of issue, but language are not really usable for real-time or embedded programming, and looking for fast thing. And the first part of my talk will be basically talking about how to make things fast, and the second part, how to make things safe. So if most of you coming from system programming, what I will talk about in the first part of my talk will be really trivial. So I don't know if I can make a quick poll around you, or who are really comfortable in system programming and know what's, I don't know, package config, and are not confused with JObject introspection. I don't know this kind of stuff. I just buzzwording things. I don't know, or who, if the one who in the room who feel comfortable with system programming can raise the hand just to take the temperature of, are you feel?
Systems programmer here.
Yeah. Okay. Alpha. Okay. Nice. And so there's a lot of interoperability solution. I will not give all the name. We see ECP, inter-process communication, EPC. Sorry. In the previous talk, there is a lot of things. I put buzzword, for example, Google Protocol Buffer. That's serialized things. You can put it in a file and serialize it outside in another runtime. You could have microservices that sends, I don't know, WebSocket. We have a lot of different solutions, and to ask yourself if it's fast, will it be a performance bottleneck in terms of runtime cost? You can ask if your way of communicating use OS capabilities. For example, did he rely on input-output? Did he rely on asking something from the OS? Because if it does that, basically your operating system has the right to put your program in pause during the time it gets the answer to his question to OS capabilities, to syscall. So that means that in the ground scheduler of your operating system, there is a bottleneck every time you do an I/O. If you could not do it, it's better to not do it. And there is also always a cost in runtime serialization, deserialization. There is cool serialization formats that use binaries, which is really efficient in space. There is fast to deserialize. But if you can prevent to do this extra step, you save rest time cost. So we'll talk about the most basic primitive technique to share data between runtimes, which is FFI. That does not rely on any OS file or socket address, and does not require extra deserialization. A bit of typecasting, but not so much. And so here we go. I switched to demo mode. I did little thing. I think it's in demo Rust. Yeah, a lot of Nick stuff that's appeared in my screen. Sorry. And what I have a file that I write, which is the main, and this main. This main use an external keyword. That's the magical keyword to say to Rust, go fetch a function from the outside of your program. I will try to make two Rust programs communicate to separate Rust program without using cargo, without using the standard way of putting Rust piece of code together. And yeah, extern allow me to not have a function without a body, and this is of course unsafe. I should calling the function in an unsafe block. Everything cool, and I have a library that live in, I think, greetings repository, and that basically does nothing. I need a little extra thing. I need nomangle because I want to prevent a default things that does Rust and that does C++2, which is mangling symbols. You know, function will become symbols in binary, and symbols are usually random things created by the compiler. And here I want to not change hello, I want to keep it because I want to be able to call it from the outside. And that's not what the external keyword does. That's, you have to tell an extra thing to the compiler to do that. And I think if I do that, I need two more things. I need a build.rs customization to tell RustC linker where to find the library and what's the name of the library. And I ideally already compiled the library, and she lives in greetings target debug, and she's .ethos. It's a dynamic library. If I can recompile it to show you it works, so you can trust me. I have a warning, but I don't care. It just works, and yeah, it's compiled. It compiled. Rust just told me it's the warning. I run it. It compiled too, and it run, and I have no issue at all, and everything is fine. Since I'm consensus, I will still look at the warning. Warning talked me about C types and things, and why? And the thing is, I do not know, but extern, in fact, is an alias to extern C. Same things that what is that, because it uses the C call conventions, the way to call function in C to allocate the stack, to put the function of the stack, to free things after, and the way to usually to write the format, the protocol to put different argument and return value in C. I don't know why I return use size. It's just a mistake of mine. Don't care. I don't want C. In fact, I just want Rust. So I put Rust here. Yeah. And if I go to my greetings folder, oh, sorry. It's I want to say Rust here too, but you know, external Rust, in fact, it's not needed because all the functions use Rust call convention. All the functions are external by default. The only things you need, in fact, is not the external keyword. It's the numangle. That's the things we care. So this works. We just don't touch the symbol. We do not need the external keyword. And if I build that, it will works without warning, so I'm really happy. And if I go back to the main folder and I run it, can be formatted with the default formatter. Yeah, I know that's because I didn't test my code. That's not part of the demo. That's just I'm dumb. I already calling println in hello, I guess. It does not return anything, so I just need to do something like that to make my demo work. Why do I need unsafe? Because it's still in the extern, so the function just live outside my. I still need unsafe. I'm pretty sure of that. I will test because it's the only way to know. Yeah, it's unsafe because it comes from outside. So I still need unsafe here. And here we go. And it works. It works, and I'm really happy. And you don't see that it works because you have some. Oh yeah, why you display that? Yeah. You have a part of my screen. Yeah, you see it. It works. Sorry. Don't care. And I'm really happy. Everything works, and so stalking is good. And maybe you know it's. If I try to recap, all functions are external by default. External defined call convention used. It's not about visibility like a pub keyword, a super pub keyword. Or if I use only extern, it's syntax trigger to extern C, and if I put an extern block, I could define into it function without body. And numangle is a thing that I need to do linking, in fact, because it's a thing that preserves symbol. It's a real thing. And the thing is, I should not at all do that because I have an issue, which is everything works, and everything works because I I hacking to make things work, and I finally find a way, and everything works. But it works against some things that should not be used, because the REST SQL convention is not publicly specified. It exists in REST documentation, it exists in REST code, but if I compile one library into a dynamic file, for example, with a version of Rust, and link it with a program in another version of Rust, I have no guarantee at all that it will work. And if it breaks, I don't know how it will break. I have no guarantee of what this or it will, I don't know. And so I should not use the REST convention. I should use the C1, which is why that's the default behavior of the external keyword, because this one is specified. And I try to make the differences between things that are specified internally and specified publicly, because first category is an hack, and the second one you can build stuff on top of it without fears that it will break at any moment. A lot of things in Rust are not specified publicly. The early format, the default format, where all the library are easily built, not like the thing we did that, are unspecified. All the intermediate languages are unspecified, so either you generate Rust code that will still compile, you know it, either you generate something really low level like LLVM, but HTML, the intermediate language are not. A lot of things are unspecified in Rust. Default memory layout for struct, default, so you should not rely on it. So the only things you could rely on it, if it works, sorry, I lose the focus on my terminal, it's the CABI, because the CABI have a lot of quirk, but at least it's stable. I mean, if I build something relying on CABI, it will still work, because it will not change, and it's really a great feature of what we do here. And I have another example, quick example, I think with Python. So here I show you how I should write my previous code. You see I take Rust C types, which is FFI safe, which was the previous warning I got. And so I should do some unsafe things to turn it into Rust str, and at the end I can did it the right way. Just a little things for the next part, the safe part. When I use the unsafe word, because there is a lot of unsafe going out here, I always try to use it to wrap it the less code possible, because it's really easy to have things that I think is safe wrapped into an unsafe block, but in fact which is unsafe. And the good practice for unsafe block is to make it the smallest possible always, and because Rust, everything is an expression, it's easy to do that. So unsafe should be used in a way where it's a few code written in, and I have main Python files that load my library, and I think that should work if I can go build my thing. Yeah, it's already built, but anyway. And now, yeah, everything works. So I load Python code into Rust by using C string call convention. So everything cool, and I'm really happy with that. And now, for the safe part, know that it's really hard to write FFI by hand, and when you do it, usually you fail it, because you're in a space between two runtime where there is no type checking and no mechanism to check that what you did work, just function pointer at the end. So if you forget an argument, if you forget a field in a struct, if you interface don't exactly match, you will not know it at compile time. Most of the time you will know it at the worst time, at runtime. So you always prefer to do binding generation, and there is a lot of solution for that. You can generate binding from a C file, an header file, to Rust. That's all the crates that are suffix sys when you install cargo with Rust by Gen. There is a live coding video by John Jensen. I don't know what's his name is pronounced. The author of Rust for Rust ASEAN on YouTube, which is pretty cool, where it general binding for libsodium, I think. There's a lot of stuff to embed Rust into other language. There was Mbak was by Gen. There is Maturin and Pio3 in Python. There's C by Gen for C, and there is a little thing I did for Haskell, which is the point of this talk, to advertise a little thing that I did. And there is really cool things that do both, that offer binding in both sides. And the 6.6 crate by David Tolnay is really cool, and there is a recent initiative in OCaml with OCaml Interrupt. It got a lot of funding. We got funding. I don't know if it's a lot of. So there is things that's occur, and the question you want to ask is how I do binding generation in Rust. So I mean how I generate Rust code, and the answer is obviously with macro, because that's the way we like to generate a lot of Rust code. And so the last little demo, is I have a demo Haskell, where I have two things. Don't care about the next file, but I have greetings and test folder and a Cabal project. Cabal project is just a cargo workspace thing where, say, I have two packages, and at the end I want to do a Cabal run test. I will fail to do it right now. And the greetings is my really useful Rust library. I already write 3 times, where you can see the code. It's here. And now I use this little, it failed because it's, I don't know why, I don't care, Rust Analyzer. I have this little proc macro decorator on my function. So my function look like a Rust function, and I'm really happy with that. But what happened is, if I do cargo expand, which is a really cool tool by David Tolnay again, I can see my macro is expand to some wrapper of my functions that does the really dirty things of wrapping my type into C type. And this macro does another cool thing, which is, if I can go build, it also generate the binding, the Haskell binding, here, which is, I have the right type and everything, which is Haskell C types, not perfectly ergonomic right now. And so now if I just does Cabal run test, it's cheating. It will, I also, does full compilation and of everything, and at the end work. And I have a Rust dependency into an Haskell project. It don't feel like I have a Rust dependency, and that's work because I have already the Cabal file, not the setup here, generated. You don't see when I have already the Cabal file generated, and that's because I have a little handy tool that does bind the generation of the project, the file you need in the project. And so I think I talked a lot, and that was the end of what I want to show you. And there is a little repo with what I do, and that's really early prototype, and I rewrite it entirely in the train coming to here, because writing procedural macro is really painful because you have to work on the REST AST directly. So the thing you have between the end is not really Rust, it's token, and so I wonder how, if, for example, you alias, you create your own string type, my proc macro will don't know that's your own string type and will say, okay, it's look like a string. And so I changed it in a way where he use trait to actually see if it's a type where there is an implementation where I could do the code generation with it, which is, I think, less dirty. And that's it, and I could talk about everything later. And last things, you know the Rust example, I forgot to say that, the Rust example where there is a Rust code that include the Rust code with dynamic library, which is using the Rust call convention, which is bad. This code, if you try to include it with static library, will not work. And I don't know if you know why, but I could give the answer later. It will not compile for any reason. Yeah, and thank you for your attention. Thank you.
Thank you so much. Time for questions. Talk in the microphone. Thank you.
Hi, thanks for the talk. It's actually very interesting to see a bit of FFI. I know how it works more or less. I never use it myself. So my question is, if you let's say if you use FFI to let two Rust processes communicate with each other, have you noticed any performance hit in that? Like in using a common C ABI to communicate data between the two processes, or have you noticed any kind of performance degradation?
I think there is two answers to this question, which is always the theoretical one and the real life one. And the second one, I think that benchmark is the only trustable things for performance measurement. But in the conceptual way of seeing it, casting to C type is always a bit costly because it's typecasting, so there is a few operations involving into it. And also, static library is, at the end, is the one big binary, so you don't really realize that you call a function from outside. But dynamic library, it's really like you're loading another executable that you will be able to do a call into it later. So that's a bit of extra runtime cost at loading, but I think it's mostly it's not a lot of cost comparing a lot of other interoperability solution where there is a big communication runtime cost. So I don't know if it's answering your question. Yeah.
Yeah, we don't have the cool cube here anymore.
I agree. That was, a really nice talk. My apologies if you answered this at the end already. I wasn't sure. What is the story for passing user-defined types across an FFI boundary?
The thing is, when you write a proc macro, okay, no, it's complicated. When you write a proc macro, you basically operate on top of an AST. So it's just a bunch of tokens. So it's basically a fancy constraint, which is not a string, but it's really close to a string which contains your whole program. So it's like it's Rust, but it's not interpreted as Rust. You have token, you have chunk of string typed like parsing does, but not like it have no semantic meaning. So you just know, okay, I have an argument, and at the token for its type, it's I don't know. String is a good. How to say that? It's a string. You don't have the meaning of what the type is, so you prefer to not match on token, because matching on token is just matching on string, which is a key. For example, if I have a custom defined type, and I prefer to define traits, and traits just say if a type implemented this trait, I know what's the primitive to cast it to something which is a good C type, and I get the information of what will be the generated Haskell bindings on the other side. So that's the strategy. But the strategy I want to explore right now is J-object introspection, because this problem is well known by the NUM community, and there is an implementation in Haskell that's pretty cool. That would allow me to have more complex type, and that's my guess. And yeah, J-object introspection is just you have like a magic metadata you put side to your type, so you can say it looks like that, the memory around. So you have a way to know what's the coming memory attached to a type, thanks to metadata, to simplify it. Yeah.
Thank you.
Okay.